custom for us and head biomechanics of the World Tool team BISMA, with extensive experience working with elite athletes. John is a leading expert in cycling biomechanics. He will get used throughout the key features of the PPA system and share insights on how it can be used to detect asymmetries, optimize pedaling, and support evidence-based decisions. John, welcome, and the floor is yours.
Thank you very much, Odilo. Thanks also to everyone for attending this webinar. This will be recorded and sent to all the audience. So if somebody is interested in see it again, it will be sent it to your email after being finished. So my exposition will be around 20-25 minutes, and then I will left some minutes for some questions or maybe some interchange of opinions about the use of our system. As Odilo said, I will show how I'm using right now this system, both on my practice and also with the pro team. And I hope that everyone will find it interesting. As you will know, probably it's very easy to use right now. And most of the people find it such a kind of interesting characteristics in order to be optimizing the pedaling of the rider. So, okay, this is the presentation. I'm Johnny Berry. I'm from the Basque Country. I work as Odilo said in a custom for us company. I work also with the pro team BISMA, and I'm now an advanced user of the pedaling pro system with more than a year of experience with the pro cyclists, but also with the amateurs. The story starts here when we used the old torque measuring system. On the right, you go probably you will know the spin scan system that was used on the race-made roller, but unfortunately 5 years ago or something, they decided not to go on with the device, and actually can be used but cannot be bought. So it was a good place where we were making some research and experiences and everything for knowing what happened with the spin scanning of the riders, but actually cannot be bought. So it is not really with one device with a lot of future. At the starting, 20 years ago, we measured everything on the laboratory with the SRM system, and we published at that time, 22 years ago, some papers about the analysis of the torque with the existing evidence about how to evaluate, how to measure, how to optimize, and okay, till today. We have been working for 20 years from the point of view of the research in this topic, and I will try to expose you what we have been looking for, what we have found, and I hope that is going to help you in understanding better the pedaling torque. So the torque, as we right now measure in just one signal, is just the addition of two signals from the left-right crank and pedal and the right one. So the addition of these two torques, the positive and negative values, are just on one line that was measured at the start with the SRM system, and actually we will do with several power meters. You can see on the right that it's a very big difference between the cyclists and the non-cyclists. So we have been thinking from the start that the way of pedaling and the way of making the circle of the torque during the pedaling stroke could help us in giving more technical information to the rider in order to optimize it. So we will show you how we work. The pedaling pro system is used during the exercise for having what I'm going to show you on this presentation, just when we go high data rate. Cannot be measured. For measuring the torque, we need a lot of data per revolution or per second. If there is just 1 second, as in the NT plus systems, it's impossible to measure the torque. So we need high rate data. I will show you which devices are going to be used for showing what I will show you to you. And if it is not possible because your power meter or your roller is just giving low frequency data, it can be used for doing after the session analysis. So cannot be live analysis, but you can do the analysis, such a kind of analysis, after ending the training session, competition, or whatever. This is a kinetic analysis, so it's far from different from the kinematic analysis doing in biomechanics by systems as Retool, as Bicom, as STT, and this kind of one. And this is the complete frame set of the pedaling. So when we are measuring this, we also normally do video recording for doing the kinematic data, but obviously it is not topic for today, and I will just to show you what we are doing and we are measuring from the point of view of the kinetic analysis of the moment. And everything is based in the relationship between the power and the force that is doing related with the currents also during the pedaling. So what's on the schema? So we take the measurement from the power meter of the rider, and we can see on the computer it's wired, it's wireless, sorry, and we can see the data live when they are pedaling. In this case, we are taking the analysis from the power meter of the rider, which is a quark, as the SRAM voltmeter, and the rate of the analysis data is quite high enough, and the precision and accuracy of the system is quite good. But as I said, the software can be used with any different devices. As this example, as we work with the team with the quark power meter, so we adapted this. So we got this for, yeah, you can see what you can see live on the screen when the rider is pedaling, and you can see what is done with the right leg, what is done with the left leg, the balance and different parameters that they can be assessed. And I will show you one by one the different cases for evaluation and assessment of the torque pedaling. So the first one is the medium torque. So this value on the right, as you know, the medium size of the two dunes, is the medium value measured in absolute values. This case, for example, 38 newtons per meter. And if we make a relative value based on the mass of the rider, we got also the 0.959, Newton meter per kilogram. That is the unit for the relative value. This is giving us the amount of force done for this pedaling, not just the left or the right one, but just for knowing the medium value of the whole cycle with right and left at the same time. This is very closely related with the amount of power that you got up on the right on the screen. So in this case, 281 watts, and it's related also with the amount of RPM, so the currents that is showing the rider. So these three parameters are going to be always very related. So the amount of force, that is what we are measuring here, the amount of power, and the revolution. So they are directly related between three of them, and we can get power based in a high torque and low currents, or in a high currents with low torque. So based on this, we do the whole analysis of the whole differences of the pedaling behavior. So the medium torque is the start of everything for knowing the amount of intensity of the pedaling. The second one, that's a little bit more complicated, is the relationship between the maximum value and the minimum value of the torque when you are in around 90 degrees and when you are in around 180 degrees, both on the left and both on the right. So this relationship, the longer it is, the better is going to be the mechanical efficiency and the metabolic efficiency of the rider. So we got here this parameter, for example, 11% both on the left and on the right, for giving us the green value. I have not explained this, but it's quite easy to try to understand. We have developed a very easy to understand and very easy to see system for the feedback. When it is green, means that the value is good or not. When it is orange or yellow, means that it's not so bad, not so good. And when it is red, means that the value is not good enough. Okay, so in this case, 11% of value of the valley, between the valley and the mountain, so the amount of force done in the dead spot score, the dead spot point, is 11% of the maximum. For us, is good enough. So that pedaling is fluid enough and is quite inertial pedaling. So it means that it's saving energy in terms of applying the force in the proper place. The second one is this measurement, that is the amount of angle archer that is on each pedaling and 90% of the maximum. Then I will give you the literacy and the biographic basis of everything. Each article and each parameter is basically one article that we can find that is helpful in trying to analyze the pedaling. And in this case, the longer is the arch and 90 degrees of the maximum torque of each leg means that the pedaling is more better than more stronger. So one could imagine or make intuitive that think that the higher is the mountain, the better is the pedaling. But it's not exactly as that. It's not how high it is, but more how high and wide is at the top of the mountain this pedaling. So if there is a high pedaling, but the 90% value is short, means that the pedaling is not good enough to try to create in the amount of needed power by the rider. Okay, we are going to see some difference. On this case, we are in 47 degrees in green and 48 degrees on the right. So we are using a large amount of degrees for creating a force at high level. So it means that the rider is doing a great pedaling. This is a very big difference between good pedalists and bad pedalists. There's incredible difference between cyclists and non-cyclists, but also is a very good parameter for knowing if the quality of the pedaling between very, very good cyclists and medium-level cyclists is a very sensitive parameter. The third one could be the ankle stiffness. The ankle is the transmitter of the force between the hip, the knee to the pedal, and we make a relationship between the 45 degrees torque between Q1 and Q2. So the same point, which has the 50% of the tangential and 50% of the radial force for making, and see what is the difference between them. On this case, you can see that this line that is on the middle is in red. Means that the second part of the pedaling is much more stronger than the first one. Means that the rider is not able for pushing at the start of the pedaling and is just able for pushing on the second part of the pedaling. This is a very good system of saving energy, but is really bad from the point of view of creating power. And several riders, as we can see, they are not able or making the not accelerative torque strength on the Q1, and they are very limited pedaling factor, and they are limited riders just because of this. So this parameter for us is really important. Our relation is with the ankle stiffness, that there are other parameters, for example, the two high currents that is also affecting this one. So we try to find a similar value between Q1 and Q2, and this, in that case, this line should be flat and green. This case, as it is Q2 and Q1 difference, so we are going to find the red line. That means that it's not a very, very good pedaling. When we talk about the acceleration of pedaling, we measure the torque on 30 degrees. This case, for example, we are looking for 55. It's orange, so it means it's not dramatically bad, but it's not good enough. So acceleration of this pedaling is not good enough. So when we got the starting of the pedaling, the acceleration is crucial for creating big torque on the medium part. See, this acceleration is it's not as fast, as good as we could need it for a very good pedaling. means that that rider is not going to be able for accelerating the pedaling fast. In fact, it's going to be a not very fast rider at the end. So this is a factor that is well done when the rider, for example, is a sprinter, and it's not as good as when it's a very long-term endurance rider. So the 30 degrees torque key, measured as the Q1 acceleration, is the next parameter that we are using. The next one is this number that is on the middle, that you can find on the left leg, this kind 48%, 52%. This is the balance or the imbalance that we can be reading on our power meters. The difference between this is that we are measuring the whole amount of area of each mountain. So it's not just the maximum value, but also the amount of total effort. So you can find that there is symmetry without being symmetry in the middle of the mountain. So this is maybe needed to be explained. When there are the most important thing from the point of view of balance or imbalance of the pedaling is this number. It's not the high or not high of the mountain, because the way of creating the strength between left and right in some riders is different, but that doesn't mean that they are not symmetric. It means that they are not pedaling exactly equal with the right and with the left, maybe because of the reason biomechanical or physiological. But the most important thing in terms of maintaining the inertia is to have exactly the same amount of force on the right and the left. For us, for example, 2% is the starting of problems of imbalance between the right and the left. If there is 2 or 1%, could be that, okay, you can improve it, but it's not very dramatic, the difference. And obviously, we are always searching for the 50-50. That could be that the measurement of the force is exactly the same on the right and on the left. So you got this number for addressing the left and the right leg, for making the comparison between the one and the other. So what we are using now for having this deep analysis in terms of power meters, they are the quark, the rotor, and we are probably going to improve our portfolio of signals to the Fabero Axioma, to Magene or to Shimano in the incoming weeks, months, or wherever. As we are comfortable with the signals that we got for us, so depending on what the public, what you are looking for, and what you need, that we could make the development to try to use any kind of signal. Because as I said at the start, some of the signals are very weak. They don't come a lot of torques per second, so we are unable for creating the analysis because the signal rate is too low. But we are trying to make some different analysis to try to use all of the signals in order to be able for addressing the pedaling. In the rollers, we are exactly the same. We are using the Elite XT or XTR. In the incoming will be the Racermate and other models that you maybe are using now. So as a recap, for the live signal, we need a very high data rate. And if you don't have the right, we cannot do the live analysis. We can do what I'm going to show in the second part of my presentation. For some of you that maybe are interested in knowing where are the references for telling what it is good, what is not good, why this is good, what is not good, here you go the authors of the research and the parameter related with this article, so you can easily find the articles in the bibliography in order to knowing how we address and how we make the assessment of a pedaling of this way based on that bibliography. So every parameter has at its minimum of one bibliographic reference for knowing what the assessment is coming from. If we go to the post-session analysis, as I was explaining on the first time, we can have a complete report of one session. For example, this one that is the left part is the graphical analysis, what has happened with your pedaling during the training. On the right one, some examples of some of the live analysis, but for being addressed after the training. if you don't have high rate pedaling analyzer, the second part of the colors, this one on the right that I am signaling, will not appear, and you can see only the left data to try to make the evaluation after the session and doing the post-analysis. So with low data cannot be a live report and live feedback. You can just make the evaluation after analyzing the feed file. What is important for us is to show in our system how much of the job has been done with the source of muscles or with the source of non-muscle forces. You will know probably the total amount of the power that we measure on our power meters is not just coming from the muscles. If there is one part that comes from the muscle strength, that is logical, is the biggest part, but there is a not insignificant part that is coming also from the inertial movement, basically the movement of the foot, the movement of the crankset, and the movement of the bicycle if we are talking about somebody that is on the road. So as you can see here, a recovery session, it's very characteristic because the amount of muscle energy is lower compared with the other examples, and the inertial exercise and the inertial amount of energy is very high. So this is a lot of movement with not a lot of wasting energy. On the second example, you can see that during the different parts of the session, we have been addressing different ways of using and not using the muscle strength. So sometimes we use more inertial strength and sometimes we use more muscular strength. And the third example could be the competitions. And during the competition also, the riders, they manage the energy in a very different way. They try to save energy using inertial pedaling. And some of the times they use a lot of muscle because, for example, at the end on the sprint, the inertial energy is pretty low and the muscular energy is coming practically to maximum, to more than 70% of the amount of total inertia. So it means that the rider, without knowing not a lot about this, they use and they manage the currents at the strength in different ways, in different situations, and we need to make the addressing and we need to make the assessment of this for having a good and deep knowledge of the pedaling of our riders. If we talk about the mechanical efficiency and we relate it with the currents and the power, that is something that is changing basically the whole time. In this example, for example, we can see that the theory say when the intensity increase, the mechanical efficiency increase too. So we got one funny example when the left value of this rider is not improving and the right one, it is improving. So it's the same rider and it's not the same leg, but it's both legs of the same rider. So it's funny because with the intensity, one leg answers really well and the other one doesn't answer really well. So this is interesting because probably we can find a biomechanical reason why this left leg is not answering in terms of mechanical efficiency as good as the left one. This is an example of one assessment that we do daily with our riders. In another case, in theory, we can see that the more the currents is used, less mechanical efficiency appears on the rider. And in this case, we can see that this rule, it is as we can see on the draw, but it's not exactly the same with the right and with the left. So we need also to do an assessment about this to try to reduce the mechanical efficiency as less as possible compared with the baseline, this kind of 70 RPMs of pedaling. But sometimes we got great subjects that they are able for pedaling above the rules. So they are able for improve the pedaling mechanical efficiency when it is increasing the intensity, and they can do it very well in the green zone. And also they can increase the mechanical efficiency when the currents is improving. This is going a little bit against the general rule, but this is one of the characteristics of the good pedalist. in a conclusion, we could say that if you want to pedal faster, you need to pedal better. So for pedaling better, don't go fast, go slow probably, and then time to time when you are skilled in pedaling the proper way, when you can do it quite fast. One of the problems that we see that the people try to go fast in terms of pedaling, when they don't know exactly, the brain are not able for controlling the movement of the legs in the proper way, and all the parameters of the pedaling are wrong because the brain is not able for pushing the pedal or not pushing the pedal in the proper situation. So happens what we have seen in the previous analysis. So this could be the gold standard way of pedaling probably. Another factor that we can include in the after the session report is the influence and how is the manage of all this related with the profile, because obviously the rider is not going to do the same uphill, downhill. So we see on the blue line how much of the power has been used related with the profile, that is the orange mountain, and then we can make the division between the inertial and the muscular energy for knowing when has been saving energy and when he has been using a lot of muscular energy. This is giving us the report for analyze the race, for example, or the training, depending which has been the aim of the training. We can see if the rider has used the force and the currents in the proper way related with their aim of the session, of the training, of the competition, or whatever. Another kind of analysis is, for example, see the different uses of the currents and how the rider meets a little bit the use of the force depending on the direction of the objective at the end of the session. In the left case, you can see a low intensity session with some points, red dots, that there means that there is the power is low and the current is quite high. We got a green line in the middle that should be the relationship, the self-selected relationship between the demanded power and the currents, and the orange should be the force-based zone. So in this session, for example, in the left one, we can see that he has been saving energy and using a lot of not adaptative way of creating the force. So basically in inertia for saving energy in zone 2. And on the right, we got just the opposite example. Not a lot of use of low intensity, a lot of use of orange part. That means that they are having a high intensity training of more than 4, 5, 6, 7, even 8 watts per kilogram effort. And they have it done also with not a lot of current. So the muscle demand has been extremely high. So a high muscle adaptation session looking for improvement of the force of that rider. The so-called torque training, for example, could be a good example of this. So you can see on this graph the difference between the muscle orientation of the session, the training, or the race if there is analysis of a competition. Same parameters, but we can see how much of the time of the session has been dedicated to force, how much of the session has been dedicated to recovery, to high adaptation pedaling rate, or energy saving. So we got two very different sessions with two very different profiles for knowing exactly that the left session has been an probably recovery or long-term endurance session, and the right one has been based in a high torque adaptability session. So more than a quarter of the time has been using for making a strain over the pedal. So it's a very, very extenuant session of training in terms of muscle adaptation. Other thing that we can see during the session is the evolution of the gross efficiency and the mechanical efficiency over the time. So we can see that in 3 hours on the left graphic, we can see how has been the evolution. So we put it on every half an hour, the medium value of the gross efficiency and the mean efficiency during the time for knowing it has been going down, has increasing, depending on the power, depending on the aim of the session, so depending at the end of the day of the rider. And we can see at every session how has been the management and the relationship between the gross efficiency or the metabolic efficiency and the mechanical efficiency of the rider during the time. And then on the right one, you can see also how has been, we mentioned it before on the live analysis, the arch of 90% of maximum torque, how long and how has been the percentage of different intensities, for example, 4 watts per kilogram, 5 watts per kilogram, 6 watts per kilogram, 7 watts per kilogram, how much has been the number of degrees of this. As we saw on the live analysis, you can see that over 40, 45, it's a very good analysis, and most of the pedaling of this intensity has been a very, very good. So it means that this rider is pedaling really, really, really in a top way of pedaling and a very effective way of pedaling. Obviously, it's a very good rider. Other possibility that show us the post-session analysis is the use of the strength basically in a very short series in a very low rate of pedaling. If you can see 24, 22, 26 RPMs is a very, very low cadence and is related with a new way of training the force in the bicycle that has been published in the last 2 years, based in the research of Dr. Payares and Dr. Barranco, that they have made a large amount of research talking about how the force should be training over the bicycle to be successful and for being useful. And we have created one graphic to see this, if this been adaptable or not adaptable charge. So for example, if we see that it's in the red area, the spots mean that that repetition has not been very useful. In the yellow one is medium term adaptation, and in the green one means that that pedaling and that effort has been useful for having a very good analysis and a very good adaptation to the force. I'm finishing with this, and just the mention of, if we add the values of every session, we can also make an assessment looking for evolution, in this case, for example, of the gross efficiency and the mechanical efficiency of different riders in long-term space of time. So, for example, more than 200 days or 250 days, one season could be, or one part of the training, and the evolution is quite paradigmatic. Several cases it is improving, several cases after doing something changes, and this change is reflected on the gross efficiency or maybe on the mechanical efficiency. So this is measuring what happens with the training, what is happening with the pedaling technique, if it is changing or it's adapting, what happens with biomechanical screening, for example, or maybe a change just because one competition has given the competition stimulus to improve the pedaling with a high rate of power, cadence, and deep impact in the physiology. So this could be, all these factors could be changing the long-term adaptation of those parameters. So if I am right, I think that this it is finished the presentation, and I will leave off sharing my screen. And if somebody is interested in asking something, just as we are not a lot of people here, just unmute the microphone and launch your question or whatever. And again, thank you very much for your attention. So the time and the questions for you.
Thank you very much, John. Does anyone have a question?
I just lost the first 10 minutes of the session, and I don't know what you've been talking about. And if you can explain me in 5 minutes what you said in the first 10 minutes, it would be awesome. if you can't, don't worry.
I think no, it's not a problem because the session is recorded. We can send you the recording of the sessions and you can see it because the first part of the session has been quite a little bit dense in terms of metrics and the live analysis of paralleling. So I recommend you to see again the recording of the presentation because it's really complicated to explain it as a recap because there are a lot of things that has been said on that moment.
That's perfect. If you can send me, it's awesome. Thank you.
Yeah, we'll be send it to everyone that has been signed on the session. The compromise just will give the information, and you will have take your time for making the analysis or making the questions from home after this.
Any more questions?